Hello students, today's topic is covariance. Covariance measures how two variables vary together and move together. If they move in the same direction, then covariance will be positive, and if they move in opposite direction, then covariance will be negative. If covariance is 0, then there exists no linear relationship between the random variables. Covariance between x and y is equal to expected value of this one. In the next step, we will write expected value, and now we will multiply these two brackets and we will write as xy minus x times expected value of y minus y times expected value of x plus expected value of x times expected value of y. Okay, next step. Expected value of xy minus ex ey minus ex ey plus ex ey. Okay, now this will be cancelled out, and the last step is expected value of xy minus expected value of x times expected value of y. So this is the final formula of covariance between x and y. Okay. Remarks. First one is, if x and y are independent, then covariance between x and y equals to 0. We know that covariance between x and y equals to expected value of xy minus ex times ey, right? Next step, because x and y are independent, so we can write exy as the product of expected value of x and expected value of y minus this term and last step is 0. So if x and y are independent, then covariance of xy equals to 0, but the converse need not be true. If covariance is 0, then there exists no linear relationship between x and y. Second remark, covariance between ax plus b and cy plus d equals to AC times covariance between x and y. We can prove this as we can write the LHS in this form: expected value ax plus b minus expected value of ax plus b cy plus d minus expected value of cy plus d. Okay. Next step, expected value ax plus b, and this will become a ex minus b cy plus d minus c ey minus d. This will be cancelled out. Next step, expected value a x minus ex, in the same way c y minus ey. Next step, AC times expected value of okay, and the last step is AC times this term. This term can be written as covariance between x and y. So we have proved that covariance between ax plus b and cy plus d is equal to AC times covariance between x and y. Third remark is covariance between x minus x bar upon sigma x and y minus y bar upon sigma y equals to 1 upon sigma x times 1 upon sigma y into covariance between x and y. Fourth remark is covariance between x and x equals to variance of x. It can be proved in this manner. We can write the LHS as expected value right. So we can write the LHS in this manner. Next step, expected value of x minus ex whole square and we know that this is the formula of variance of x. So we have proved that covariance between x and x equals to variance of x. Fifth remark, covariance between x plus y and z equals to covariance between x and z plus covariance between y and z. And last remark is covariance between x plus y and z plus w equals to covariance between x and z plus covariance between x and w plus covariance between y and z plus covariance between y and w. Okay. Now we have given this joint probability distribution, and the first question that we have is, are x and y independent? So this is a very simple question. Probability that x equals to 1 and y equals to 1 is equal to, so x equals to 1 and y equals to 1, that is 0.2. So we will write 0.2. Then probability that f x equals to 1, it is f x equals to 1, so this is 0.5. We will write 0.5. Now probability that y equals to 1, probability that y equals to 1, it is 0.4. So we will write 0.4. Now since the joint probability that x equals to 1 and y equals to 1 is equal to the product of their marginal probabilities, you can see that 0.2 equals to the product of 0.5 and 0.4. Therefore, x and y are independent. Done. Next part, find Ex and Ey. So let's first find out Ex. Okay. So when x equals to 1, its probability is 0.5. So when x equals to 1, its probability is 0.5 plus, and when x equals to 2, again its probability is 0.5. So we will write 2 and 0.5. It is 0.5 plus 1, which is 1.5. Okay. Now let's calculate expected value of y. When y equals to 1, its probability is 0.4. So when y equals to 1, its probability is 0.4 plus when y equals to 2, its probability is 0.6. 0.4 plus 1.2, which is 1.6. So expected value of x is 1.5 and expected value of y is 1.6. Next part, find variance of x and variance of y. Let's first calculate variance of x, and to find it we need ex square. Okay, and it will be calculated as in this way. So its probability was 0.5 and 0.5. 0.5 plus 2 square times 0.5, it is equal to 0.5 plus 4 into 0.5, which is equal to 2.5. Okay, now variance of x, which is ex square minus ex whole square. So which means 2.5 minus expected value of x was 1.5. So 1.5 whole square, which will be equals to 2.5 minus, it will be 2.25, right? And this is equal to 0.25. Okay, so variance of x is 0.25. Now we will calculate variance of y, and for that we need to find out ey square, which will be and fy was when y equals to 1, its probability is 0.4, and y equals to 2, its probability is 0.6. So we will write 0.4 plus ey square is 2.8, and now variance of y, EY square is 2.8 minus expected value of y. Expected value of y is 1.6. So 1.6 whole square, 2.8 minus 2.56, which is equal to 0.24. So we have calculated variance of x as 0.25 and variance of y as 0.24. Next part, find covariance between x and y. So let's first calculate expected value of xy Next step, when x equals to 1 and y equals to 1, their joint probability is 0.2. So we will write okay. When x equals to 1 and y equals to 2, their joint probability is 0.3. So when x equals to 1, y equals to 2, their joint probability is 0.3 plus when x equals to 2 and y equals to 1, their joint probability is 0.2. And when x equals to 2 and y equals to 2, their joint probability is 0.3. So it will be 0.2 plus 0.6 plus 0.4 plus 1.2, and this will become 2.4. So the expected value of xy is 2.4. Now we will calculate covariance between x and y. It is exy minus ex times ey. It is 2.4 minus expected value of x was 1.5 and expected value of y is 1.6. It is equal to 2.4 minus 2.4, which is equals to 0. Okay. Next part, find correlation coefficient. The formula of correlation coefficient is covariance between x and y upon the product of standard deviation of x and standard deviation of y. In our case, covariance between x and y is 0. So we will write 0 upon sigma x times sigma y, which is equals to 0. Okay. Next question. We have given this function as x plus y and the range for x and y is given as 0 to 1. First part, we need to find marginal probabilities. So let's first calculate fx. Next step, this will become x plus 1 upon 2. Okay. In the same way, we can calculate fy. And this will become 1 by 2 plus y, which can be written as y plus 1 by 2. Okay, so we have find the marginal probabilities as fx equals to x plus 1 by 2 and fy equals to y plus 1 upon 2. Fine. Next part, find expected value of x and expected value of y. So let's first calculate Ex. Fx was x plus 1 upon 2 this will become x square plus x upon 2 and this will be x cube upon 3 plus x square upon 4 next step 1 upon 3 plus 1 upon 4 and it is equal to 7 upon 12. So the expected value of x is 7 upon 12. In the same way, we can calculate expected value of y. Fy was y plus 1 upon 2. and this will become okay. So we have find Ex as 7 by 12 and Ey is also 7 by 12. Okay. Next part, find variance of x and variance of y. To find variance of x, we need to find first E x square next step fx is x plus 1 upon 2 this will become x cube plus x square upon 2 and this will become next step 1 upon 4 plus 1 upon 6 and it will be which is 5 upon 12. So we have calculated Ex square as 5 upon 12 and now variance of x will be Ex square minus Ex whole square. This is 5 upon 12, right? Minus Ex was 7 upon 12 whole square okay. So variance of x is 11 upon 144. In the same way you can calculate variance of y, and variance of y will also be 11 upon 144. Okay. Next part, find covariance between x and y. So first we will find expected value of xy, which will be calculated as okay. and fxy is x plus y. So first let's integrate this function with respect to y. So this will become x square times y square upon 2 plus x y cube upon 3 and this will be x square upon 2 plus x upon 3, and now we will integrate it with respect to x. So we have calculated exy as 1 upon 3, and now we will find covariance between x and y, which is exy minus ex times ey. This is 1 upon 3 minus ex, it is 7 upon 12, ey is also 7 upon 12. So the covariance between x and y is minus 1 upon 144. Okay. Last part, find correlation coefficient. We know that the formula of correlation coefficient is covariance between x and y whole upon standard deviation of x times standard deviation of y. Covariance between x and y is calculated as minus 1 upon 144 whole upon standard deviation of x is under root variance of x, which is 11 upon 144, and in the same way standard deviation of y is 11 upon 144 under root. Next step, this will be cancelled out and correlation coefficient is -1 upon 11. Okay. Thank you.